Today, date is 16th of January 26th. 16th of January 2026. The time now is 2:21 a.m. Basically, had some issues on the notifications outside, but I'm gonna mention it. Consider the beggars word because I'm trying to do my video, but I just believed that I left one belief to disclose. I left the computer room, but someone's not taking his meds, and we don't have this kind of problem in Nigeria, but he has to take his meds because he woke up late. And that's what I'm saying. He woke up late and he's not taking his meds. So what I'm saying. So the morning he's not taking his meds. So he's not taking medication, but I have the video anyway. But just cover my back because he's a due to medication, but I don't take medication. So I'm just saying stuff. I take his morning meds, because they have to do what to do, and that's what's cranky in the morning. He's fine normally in the morning, but he's not taking his meds. He's been oversleeping. I don't care about that. He's lost his phone and on the bed, but he's not taking his meds. So he gets his meds first before he gets his phone. So it's kind of problematic. He's trying to in my way, but I'm not gonna mention his names. I don't really have a name to name him or her or whatever, whoever they are. I just want to make sure they're taking the meds. Okay. Basically, today's video is about Mmuko Trident booting sequence. The former polar form. So, polar form. So, let's decipher the title. So, Mmuko, M for Mike, U for umbrella, K for kilo, O for Oscar, T for which is the Mmuko OS or Mmuko systems, Mmuko operating systems. So we have a phone condition, but basically, I want it to get smaller. So, if you have a phone, if you can have a phone, you usually just have like a. So if this phone is half the size of your phone, you can get half the phone. I'm busy. I'm busy. I'm busy. So this is the phone here. The phone size. So this phone here is literally a phone I can have half the size of, but it is like literally the phones because basically someone's at the door. I think it's someone a teacher. So this phone is half the size, but we get when you get a Miko system, get a phone, Miko phone, a Miko journal, tablet, and a Miko laptop. So the phone is what you're gonna go be using all the time, but you have phones that we have holographic phones because the smaller things, the more because you have to have holographic phones. It's gonna be holograms. So that's what Miko is. So the phones are holographics, and so the phones and tablets are holographic. And the laptop doesn't have to be holographic. It can be the laptop is holographic, so all holographic. So holographic tech interface. So I'm trying to find the boot sequence today for because you want to get because it's free in acquisition if you're born in acquisition because you need it. So like I was explaining to someone, so I have this dark hair. It doesn't mean I'm superior. It means or superior or inferior. This means I'm different and have different needs because I don't have the furry hair in the way. Because I'm born something else. So if I have like a strand of hair that's longer, different color, and I'm British, and I'm a black man, it doesn't mean I'm not. Something has changed. So I have different needs. It doesn't matter what's autism or not. It matters where you're from because it matters where you're from because it doesn't matter. You have to make things differently to get that thing, to get a result. So that's what I'm saying. I've never said racism or anything, but I'm just giving examples of the reality we share. So we all have hair. Hair is a feature of the face. So that's what I'm putting on. That's what I'm talking. So let's try the logic system. So the kind of hair you have, the eye you have, they have some kind of what we call a genetic structure that you all share, like a black, being dark in complexion, not black or white, because I don't usually term black or white, because it makes more racist. Sometimes neutralize the language before I usually say. If you have because I don't know, it stops. If you being dark means you're being so you don't say the N word, so you stop being using racial slurs as well. So that's the policy very positive. You describe this for people, based on cultural freedom. So you use the animals, for example. That's even the best thing you can do because the animals give you all that traits because they could go like light mice, dark mice, or dark in complexion mice, which goes to dark mice, and for the hormones, of the immune system. So basically, for the security model, because it's secure by design. So I'm gonna give you formal proof. But I have to give you the inputs of the system. So say you have an array, Trident array. So you have a Trident structure. So look at the Trident structure. Oh, so for example, you have a shadow. So you have a OB shadow. OB has shadow, but that shadow, OB doesn't cast a shadow. OB is the heart of the system, the soul of the system, the heart and soul. He's a zone 0. So it's like a center ring, the center bubble ring. And zone 0 then get Eze, which is a king. This is a king 0 because it makes it your king 0. So zone 0, zone 0, or ring 0. So the ring is literally in the ring, but it's there's an area of the ring because you have the dimensions of the ring. So ring of zone 0 are the center of the situation model. Eze is king. Eze is king 0. The 0 is king 1, king 1. Because king 1 has priority, but he's king 0. So I'm giving you the matrix now. So you get Obi Eze, and you get Uche. Uche is the tier 2. So you get a matrix of epsilon 0 0 epsilon epsilon 1 1 0 0 1 1 and 2 2 2 2 because you get a trident matrix, but it can be a matrix that you get matrix here. You get matrix here. This matrix represents everything that is nothing that we all share because someone's literally logging them. So you get an L system. So the L system, who wants to log in? Who's that person? So you get 0 0 0 0 0 and get 1 1 get 2 0 0 1 1 2 2. And this was saying you have simple rotation. So think about the sequence. The blue sequence is just given this scalar unit a dimension. Basically you got a dimension. So basically the dimensions means they work for Caluclus system. How that works, like if Eze is a center, Eze has a 0 0 0 0, and Uche is 1 1 1 1 in the right pole. Uche is the left pole is Uche. Uche is left pole, but he's 2 left pole. So that's his 1. So he's a counterclockwise. He's basically facing right, left. He's gonna face left. But his left is your right. So Eze's left is like 2 left, so 1 right polar rotation. So the polar rotation represents Eze and Uche's model. So 2 left, 1 right. So Uche owns 1 1. 1 1 because 1 1 because the 1 1 represents the polar color system of axis. So 1 1 is so if you get 0 0 1 left rotation right, you get a canonical unit you can share via the color quantization of it because color you get dimensional quantization. It's not just colors, it's not just RGB colors. You get the values RGBA, but you get the dimensions of the colors. The color is via what can be real. So the 0 0 1 1 and you get 1 1 which is 2 2 which is Uche. So Uche is 2 2. So because you get Eze and you get Uche, so you have this is security ring, a security design. Because it's security design because broker so if the user if you're login in the system, how this works mathematically is you have stuff from 0 0. But if you're polarized right, you have 0 1. You have to have all the trident 0 1, for example. Mathematically it's 0 1 2 0 1 1 0 1 1 0 0. Then you have to take the sequence 0 0 0. So basically your zeros you have north to the power of 3, east, north, east, southwest, southwest. So which is west. But okay, who controls the quadrant? So Eze has a quadrant northeast. He has that control. That is his dimension. This is the first quadrant. But Eze controls 1. What's the opposite of 1? The first quadrant. That's the inverse of 1, and that's 1 over 1. So that's the minus 1. So if Eze controls now northeast, he also controls. Can see east north, which is northeast. So yes, you can see the eastern side, but here's a bigger point. If you go north, you can go east then north. So you can see up and down. So which is Huamn. He has all the energy for that space and time via the Laplace integration. So that will solve this problem. So because in the path we all take, this is basically the model there is you get the path we all share, the part we all take, and all the part. So by that I mean the path we all share, the part we share as a share, which is an open share. Which is an open share. We have the path which is an open share, and we have 360 because which takes 0 degrees 90 degrees. So basically, if Obi is looking north, and which takes the measurement of Obi looking north, because the compass system, because the compass is basically having a net. So which is taking having an auxiliary sight on north. He's looking north. He's just pointing north. which is pointing north. And that north is just a standard forward. But we don't say forward or right, we say quantum spin. We have quantum spin. So the quantum spin is literally what we're polarizing on the quantum level. So, for example, if which is facing north, that means north is which is default. If OB is facing also, sorry, is this not the blue? No, if OB to left, I'm talking about which here. No, because which I'm talking about if SA, not OB. If S is facing north, no, chair. As I'm talking about SA, which is king. If echo, except for zero, zebra, if echo. Again, if echo, except for zero, if echo. And if which is E for umbrella, C for Charlie, H for hamburger, if echo. Knowledge is facing so it works because it's true. So S is facing 0 degrees. So S is facing 0 degrees. So, and that's the auxiliary. So that's the auxiliary construction. Because the auxiliary means that SA is just standing, breathing and looking north and northeast. He can turn, he can turn what he wants, but he has no move. If he then moves, he has a context switch, and the context switch will be the actual energy, and that's what because we so you got the lambda integration, which is the measurement of the energy used. But this is the noise for the noise modeling. So you get noise start full. No, this is noise sequence. The noise bit sequence and the aux bit sequence. So the auxiliary bit sequence is just the primary one. But if you need to use the noise, because there's this context switch between the auxiliary and the noise, and that is the part we all share. Because if each has a auxiliary start, that means you construct some kind of sequence here ahead of time. Because the whole purpose of this is to show there's non-linearity in the model. You can look around in the 3D world, So this is west, which is equivalent. But I'm just facing north here. But do I want to go north? No, yeah, I'm going north. I don't think about it. I just turn north. I don't think about it. I'm just processing north. There's no thought processing. I'm just looking. I'm not thinking about looking. I'm just looking. I can block my looking. As a friend, you have to test the knowledge. But if you start thinking about looking, that means you're processing wrongly. You're thinking too much, and that's using energy that you don't need to do. So you need to forget about. You need to stop thinking about looking north and just block thinking about push thinking start looking. So this is just what muscle memory does in your face. So I'm looking north. That's it. That's south. That's west. Okay. So the auxiliary structure or aux star. Say you go to aux star, which is aux star. This is geometry construction based on F pattern, collinear pattern, collinearity. So this F, which is like the other opposite, basically in a triangle, in a C, so you get opposite angles add up to 180. So if you get 180 minus, because if you get the F pattern, 180 minus 73 degrees is 107 degrees. So if you get an F, you get a 67. So that's it. If you get a Z, you get a Z, FZ T. But the Z angles in a triangle. So the Z are opposite angles, but the Z angles, so they are codependent. So they're codependent. So they depend on each other. So you look at this FZ thing comes from collinear system. So if you have an F shape, they're collinear. They have the parallel, the collinear. So you have this angle here, but it has to add up to something, and that's what's 180. Like this is a straight line. This is the line is still, but then you have to dependence here, which is just like this is codependence. Codependency between because this line is here. This is the F line, the stem of the line is the F shape. So you got this one, you go to diagonal line, but this is codependent too. FC, so you got the C, this is an F, but you got the C. So you got FC, you got the C, and this add up to 90, because there's C, but this is how I works, angles in here add up to 90, the angles in here outside how to F add up to because the Z add up to 180, they add up to 180. So if I said, because you have to think about the kind of dependency you have, and that's the job structure. Because the system thinks about what we're going to do next via the, it's really process what we're going to do next. The goals have the sort of option you're going to do next in kind of the radius of halves, for all the things, the dimension you can explore. So there's nothing to think about. So the auxiliary star of the construction model is literally ox star. Ox star means ox star, ox no star. Okay. So ox star, auxiliary star is like geometrical construction of the auxiliary principles. Something the path you are going to take. But if we're going to do a path, get how to start. So that's the other star sequence. So we get no signal ox star. And you have a signal ox star because the no signal ox star is not a deform. So you go to model. You can start with any sequence. You can start with no noise. You can start with noise. Noise ox star. But because the noise means basically the noise ox star means there's some kind of unpredictability on system. So it's a starting process. You can have an ox first noise star. And the ox first noise star. Ox first means auxiliary. That means the user is taking an action to start. And you get a noise star, that means the system is taking us to start for the user. Because it's a humorous OS, basically. So the system has to stop. So if you have an ox star and an ox first, if you got an ox first, the worst case is a noise star. And ox just means you're starting, your default start, your default update. And that's what the ox is default. It's not noisy. So you get no signal, which is no signal. Signal means you are getting information from the system. You are the signal period. You get the signal matrix. This is matrix basically. No signal matrix, signal, and get noise matrix, and get a no noise. So you want to work on the three Trident matrix: no signal, no noise, and noise. And this determines the trajectory of how you reach your thing. So via Laplace integration. So, for example. So if I start with noise, if my noise pointer is my head, noise pointer, you get to two other methods, noise pointer, this is Trident matrix, noise is a start, and put noise, that's the worst case, and you get the second one, on the left is no noise, no signal, so you get the worst one noise, which is the first thing, and you get no signal. No signal means you can't log in. And you get a signal. And you get no signal, you get no noise. So noise means, so basically this is basically the pointers you have. These are the Trident pointers. This is like the pointer problem. So what is being neglected in the system? What is not being started? So you have an either ox noise, or noise or ox noise. So we can have ox noise, no signal on the left side of the. Basically, this is a triangle, basically. So at the top quadrant of the triangle, you get ox noise. At the second triangle, you get ox no signal. And you get noise. And the ox no noise, it is recording my voice even. Yeah. And the ox no noise is just the third one dimension, but there are three dimensions. So who's trying to log in today? Is it Obi? So I'm gonna go back to Obi. So Obi is in a polar coordinate system, and he's at point 0, 0. He has no dimension, but his matrix. He's not just log in. So what will be his dimension? The first quadrant is the 180 degrees. So he's two left, one right, two left, and this is like a sum. The proof goes like this. Let me try and prove it. So Obi is the first one. So Obi, how is it so? Obi has to log in with Oxstar. So let me give some different parameters of this. So Obi is trying to use this pointer to make sure the computer boots, and the computer holds that triangular triangle model, because that's how the options scale for Obi. So I can never be locked out as OBR, heart and soul. Basically, this could be so the goal of this Mmuko system is to explain. So like remember, so we get I have to prove now. So we get pi or near 0, and you get pi over 4, pi over 3, and pi over 2. And so Obi has to move via these poles. These are the poles here. So, but this, you see all the information. So the information here is so this question is 1. This is north, and this is east, and this is south, and this is west. So Obi is trying to have a radius of 0.5, which is half, not 1. So he's defined a scalar 0.5, and that scalar is use my calculator. So we have for the Oxstar, the parameters for the ox noise, the scalar for the scalar system is 180. You get pi r squared. Pi r squared divided by half, divided by half of pi times a half of pi r squared. But pi r squared is just the area of it. So half of pi r squared is just the area we share, and then that's the polar area. But here I have the Cartesian model of this. So this is a system here of disjoint linear equations. Because you have potential different, because basically the thing of holding, you have to hold disjoint properties. So you have a disjoint form of this, because you kind of different form of this addition. So basically, I'm saying that I'm not saying that. So if you have a Laplace equation, I'm trying to formalize a disjoint pairing that holds. Basically you have two forms of example. If you have the derivative of rise of run dx to dy of dy, you get negative boy couldn't decide what to go for b squared, decided not to go, and it's a 4 yeah. So basically this is the parabola, the kind of simultaneous. This is called the quadratic formula. But the quadratic has many forms. You can have this have many forms. But when the determinant is 0, when the determinant crosses the line, that never changes. For a set of properties that you share. So you're trying to find the determinant using derivatives. So the determinant of sq squared plus y squared equals r squared, where r is the radius, and x is the polar x plus polar y. These are two matrices, two vectors, because the vectors are lattice joint. Lattice disjoint. So because it's a polar, because it's a streamline. So I'm trying to formalize how to use the polar, the kind of let's get into do it now. So I'm trying to have a disjoint formula that describe a system of linear equation. So you have disjoint forms. So you have one repetition that works in one system, and that system doesn't decohere because it doesn't use that form. So you have two disjoint simultaneous equations you can use, and you don't have to, and you can account for the space of storage of a system, which is 1 kilobyte, which is like 1 kilobyte, which is 1,000 megabytes, which is 1 kilobyte, which is 1 kilobyte of memory over sparse time, over 1 second, which is called 1 kilobytes per second. Because you have to process that. Because the goal of this is to sit never to think. Because you have to store memory ahead of time. It has to be look ahead competition using rift matching for rift philosophy. So the goal of this is to ensure it works as intended and doesn't break and decohere. So so I'm gonna continue doing it. So the goal of this, so how does this work? So we go to the three formula we need. Negative boy. So the discriminant is 4ac. So basically, so I am trying to formulate. So we go to the term discriminant, which is which has two. If it's divided by 0, it has to if and only if. Basically, so the discriminant is the discriminant of a prior formula. Discriminant is b squared minus 4ac. Now that's discriminant. This is the thing under the square root. So that's discriminant. So we get the other things. It can be positive or negative. No. So discriminant only occurs in certain contexts, and that's where we have this context switch between the aux star and the aux dot and noise dot. Because if the so it's basically it works on kind of curvature via what I call Fourier series. So the Fourier series is just again the digital equivalent of analog form. Of analog. So basically, that's what I call steps. So that's what we call steps in a Laplace integration. Because the steps can be 0.25 you take, but those are what goes up and down. So if you have a step like this, so this step, so it's a little step up and down, but it's what we call steps in calculus. So it can be, the step sequence. So basically, if I compress this waveform, this is a rubbish drawing because I'm not drawing it properly. But if I compress this waveform and I have the same property, it is that system. It can still be used for that purpose. It does the same job. It's the same waveform. It's the same Caluclus state. It shares the same data. Trident data. So you have so the more, doesn't matter how much you compress this waveform. How much you compress this waveform. It doesn't matter how much you compress this waveform. The compression of this waveform is literally right, up, down, left, right, It goes up and down, but this is the same way from basically they're the same because they are work on transformation. Transformation. You get enlargement all the way from or partial or you get enlargement, you get reflection, often you get rotation, and you get because there can be reflection, rotation, and illustration. And this is all so this is a part of what I'm saying. So the basic was minimizes the Trident pattern because the information is in Trident. So you get the true interpretation based on Obi, Eze, and Uche who have what is going on. Because one interpretation is correct of the system tomographic state, which is the area they share via the lapis equation. Because it's basically it's polar Lambda calculus. So the goal of this is to have this model forever. Because so you can work with the model framework. You have to work with it formally. When building mechanism. So again, so that was the question: how does Mmuko always build? How does Mmuko always build? How does he build? How do you build? How do you build this? So you get it. So you get the discriminant. So the discriminant stays the same, no matter the form of the matrix, and that's the thing also. You can't change the discriminant. You can take a listen. You want to also verify the system, but you should verify the structure and the shape. So you have a tally of 1, 2, 3, and they have some kind of a phrase series you can formalize to give you the tally of 3 to number 3 because we can have missing information. So basically, I have a signal so if you have an 8, if you have the number 8 is 8 can be I plus I equals minus I. No, I times I equals minus I, and then square root of I, square root of I, square root of I equals so I times I, square root of I equals the square root of 1 equals negative I. No, square root of I. No, 1. So this 1 I. This square root of I times square root of I equals I. So this is such, and you get I times I equals negative 1. So I made a video on it, but I can't remember how to do it. But I don't remember. So basically, you got this kind of signal which operates as a Madrid unit in a complex field. Basically, using a complex number tomography system to model it, because complex numbers have conjugate pairs that give you some information. So you have to determine what a system does based on conjugate methods. If you got item R, you got a sequence of I divided by I in some kind of structure. Maybe it's an array that holds that information, but it has some kind of structure. Because the array, what's maybe it's a matrix. Maybe it's a matrix. I times I equals negative I. But I divided by I, based on some kind of shape it has, gives you negative I. Because the array determines the structure already. So it's basically for polar characteristics. The imaginary is e to the power of I, where it's a growth of number I. So I divided by I is just one structure. But when you put that structure into a system, it has to obey the system shape. And that shape gives you the information. So that's the possible method. So someone find a video, find it for me. Because if you can find a video, go close one. But I'm saying to you, that's how it works. The Mmuko is built because you got this is the last formal updates. You got all the forms of the matrix in the product formula, and the product formula is determines the kind of output of the positive negative of the correlation between the simultaneous equation. That is disjoint. The disjoint forms of the expression. So you get this equation, but you have substructures that can give you the answer. That's what I mean. You got sub shapes. Can give you the answer without explicitly defining the equation, which is the quadratic formula. And that's what I'm saying it works. So you get these two simultaneous equations that are disjoint, and these are potential differential equations. Those are partial derivatives, and they can be potential differential equations, which means one can be used for work, and one cannot be used for doing something else while something. So it doesn't have to be used. It doesn't have to be allocated ahead of time. That's the goal of it. So the goal of it is to have this form and structure for the equation. So I'm to define my problem. Define a set of define using lapis integration and polar coordinate systems a tomographic disjoint formula that solve simultaneous partial differential equations for via separation of concern, space first, time next. So basically, space first is byte sped, time next. Objective, subjective. Use the ox and noise star boot sequence for Mmuko OX, and for Mike, Q for umbrella, Q for kilo, dash O for outcome, to have a triangular pointer. So basically, this is compass. Triangle to define a time slice compass that sees x squared plus y squared equals r squared, or x squared f plus minus y squared equals r squared. These are two functions to satisfy the equation to see what's happening via the so basically you have a reality. So the goal of this, so the sequence the sequence is disjoint and it's non-linear. It's disjoint non-linear sequence equation. So you cannot fold back to an array. So once you build, you get a structure, and that structure allows you to log them. But that structure is the same. So you can't flatten the system into an array it's a dynamic it's a dynamic library. But you can make it a static library if you want to store it. So you have the idea now that you can load that every time you want to log in, and without doing that, keep the state. So this is one library you're trying to run, and that's what Mmuko does. So the goal of this is to have this kind of system in place, and that's what Mmuko does. So let me take a picture of this. Black man. So guys, look at it. So basically, this part here is just find a set of lapises. So you have two lapises, which is like the Lambda. I'm going to try to do it now, because I have time to do it. So this is what I'm trying to. So you find a set of lapises or polar coordinates. So you get so let's say the means of value. So OB has the polar coordinate system. So OB has. OB is just looking at a computer, and the computer is like facing north, and it's looking at it from an angle of a bearing. So I'm trying to get to be the bearing is important. So OB, I'm just looking with my eyes. I'm fixing the computer with my eyes. I have a bearing of I don't think basically what's on bearings. I forgot to mention that. So I'm gonna record this. So basically, how to take a bearing. I hope my camera doesn't flip.